Hey everybody, thank you so much for joining me. Today our goal is to raise a number to the second third power and for you to understand that cubing and cube roots are inverses of each other. So a cube is literally a three-dimensional figure, and the volume of a cube is side times side times side, or side cubed. So today we're going to complete our class notes, and you're going to try your turn problems if time permits. Your homework is quizzes, and it's on cubes and cube roots. And within this Google presentation, if you click here, it will bring you to the end of the presentation where you can study your perfect squares and roots and your perfect cubes. So the first thing I'm going to ask you to do is to stop the video and try the do now problems. Okay, so if I look at this first problem, the square root of 9 squared is the square root of 9 times the square root of 9. There's a couple of different ways I can look at that. Square root of 9 times the square root of 9. That's one way. And the square root of 9 is 3. And 3 times 3 gives me 9. And then I would have to add 10 to this. So the correct answer is 19, which is C. That's one way to look at this. So a second way to look at this is to multiply the square root of 9 times the square root of 9. And because those are both square roots, you can multiply the numbers underneath, which is the square root of 81 plus 10. And the square root of 81 is 9. And 9 plus 10 also gives you 19. Okay, the second example asks you to write 0.14 as a fraction in simplest form. So remember, it is 0.14 bar, and that bar means it's a repeating decimal. So we write that as over nines, not over, it is not equal to 1400ths. It's equal to 14/99ths. And I can't simplify that fraction, so I'm all set. All right, so now we're going to take a look at cubing a number, and that means to multiply a number by itself 3 times. So I'm writing what I want you to write in the blue type here. So what is 3 cubed? Well, it is literally 3 times 3 times 3, which is 27. So 3 to the third power is another way of saying this. So why? Because 3 cubed equals 3 times 3 times 3, which is 27. 4 cubed equals 4 times 4 times 4, which is 64. So the cube root goes the other direction. It's the inverse of cubing something is to take the cube root. So you have to ask yourself, what number can I multiply together, the same number, 3 times to get the solution? So going the other way, if we use this 27, we know the cube root of 27 is equal to 3. Why? Because the number 3 is multiplied by itself 3 times to make 27. So the question is, what is the cube root of 8? So the easiest thing to do is to start with 1 times 1 times 1, which doesn't work. 2 times 2 times 2, that works. So the cube root of 8 is 2, because 2 cubed equals 8. So what is the cube root of 25? And again, I always suggest to students, make a little chart for yourself. 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, 5 times 5 times 5, and so on. So 5 times 5 times 5 is 125. So we know the cube root of 125 is equal to 5. So there's a special symbol that we use, and this special symbol means the cube root. It's the radical symbol, which it's similar to the squares, but we have a little tiny root, or it's also called an index, and it's the number 3. And so we say this the cubed root. So the cube root. So you can say it like this. The cube root of 27 is equal to 3. And that's how you would say it in words if you wanted to translate this equation. So the state frameworks asks you to memorize the first 10 perfect cubes, and they are listed here for you to use as you're going through your homework. So we're going to go through the simplified problems. So what is 2 cubed? And I asked students to write it out. It means 2 times 2 times 2, which is 8. Now, what is the cubed root of 64? If you're not sure, you can look it up. Oh, there it is, 4. What's the cubed root of 25? 125? Well, we already did that. We know that's 5. And then 10 cubed means 10 times 10 times 10, which is 1,000. So the question is, does this make sense? Okay, so now we're going to take a look at a couple of equations. We're going to solve these. X cubed equals 8. So we're going to take the cubed root of x cubed, which looks like that. And whatever we do to one side of our equation, we have to do the same thing to the other side. So the cubes cancel, and we're left with x equals 2. So the cubed root of 8 is equal to 2. On example 2, we're given the volume of a shape is equal to 125 cubic meters, and we're gonna assume that this is a cube, and we need to find the side length of this cube. So we know that the volume of a cube is side cubed. So we're going to take the cubed root of 125, and that equals 5. And our units of measurement would be in meters. It's very important when we have units that we make sure that we are including them in our answers. So the volume of a cubic box is 64 cubic meters, and we need to find the side length. So again, volume equals side cubed. So we know that 125 equals side cubed. So I'm going to take the cubed root of both sides. And cubed and cube root undo each other. So we know that our 5 is our side length. Oh, I'm sorry, it's 64. What I was doing there. So let me change that, 64. That was the problem above. So the cubed root of 64 is equal to 4. And again, we need our units of measurement, and it's 4 meters. All right, so the food for thought problem, if you look at all 3 of these examples, they all have the number 64 in them, but they have slightly different symbols. So this is the square root of 64. So you're asking yourself, what number do you multiply by itself twice to make 64? And it's 8. This is the cubed root of 64. So you're asking yourself, what number do you multiply by itself 3 times? The same number to make 64, and it's 4. Now, just like we can have a principal and a principal and a negative square root, we do have a negative cube root. And it's okay in this case for the negative sign to be inside the cubed root. We know this is not okay. There's no number you can multiply, no real number that you can multiply by itself to make negative 64. However, you can multiply negative 4 times negative 4 times negative 4 together to make negative 64. So the cubed root of negative 64 is equal to negative 4. Okay, so I'll ask you to try these your turn problems, and then you can go right into, check them, stop the video, try them, check them. Here are the perfect squares and square roots that you can study. And then the cubes and cube roots were earlier in the presentation. So I'm going to quickly go through these problems. So you might want to stop your video and then turn it back on when you're ready to check. So 5 squared is 25, and minus 6 squared is 36. And I'm going to rewrite my subtraction as adding the opposite. So I'm going to subtract 36 and 25, and that's 11. And my answer would be negative because 36 is a larger number and it's negative. Okay, the cubed root of 216 is 6. Now, problem number 9. The square root of 121 is 11, minus the square root of 169 is 13. I'm going to rewrite this as 11 plus negative 13, which equals negative 2. On the next problem, 3, and the operation between the 3 and the square root is multiplication. So this is 3 times the square root of 25, and the square root of 25 is 5. So 3 times 5 is 15. On this next problem, we are looking for the negative square root of 64, and you'll notice the negative symbol is outside the parentheses. So we know that the opposite or negative, and the square root of 64 is 4. All right, so the next one's kind of tricky. We're adding the square root of 64 to the cube root of 64. So we know the square root of 64 is 8, and the cube root of 64 is 4, and the sum of 8 and 4 is 12. Alrighty, thank you for watching this video. I hope you found it helpful. Please study your perfect squares and square roots and your perfect cubes. And tonight's homework is a nice quiz activity. It will only take a few minutes for you to do. And I wish you a lovely weekend. Thank you.